This meeting is being recorded.
Right. So, what are we talking about?
Oh, I was
It's a
hoping
good
to
question.
get us all together and see how I could best help everyone. Just kind of introductions to myself. I'm a PhD student in electrical engineering, and yeah, I'm solder certified and just build a high voltage equipment. So high voltage DC, like the Cocker Fulton, some of Hank Kieran's experiments they're using the high voltage DC for his. I also would use high voltage AC, like Tesla coils, or some other projects that the group's interested in. So this call, I think we want to just talk about how best I could help everyone. I think by building the electrical equipment and sending it to groups that are experimenting. I know I talked with George Hathaway. That's also why I want to join this group to help with networking with other scientists, senior scientists too, that have more experience and could guide me with my research into
Is
focus
George going to
on.
join us today? I don't know whether he is.
I
He
talked to them. Charles Holmes mentioned that he might work next year with him, but this call
okay?
just us. Maybe next
Okay.
call we could get him to join. Yeah, just mostly through email and some other projects like DNP, dynamic nuclear polarization. Mark Sokol, has worked with him in his lab, and they drove up there to get some equipment from him. So he has a big lab still there in Canada. So so hopefully we could work with him on some projects. He has an idea for high frequency DC circuits that could be used for experimenting with thrusters like the Campbell thruster. I don't know if you've seen recently, but we showed on APEC we got propellant propulsion. We showed it wasn't just ionic wind that were propelling these kind of crafts. And I think in one of your talks, Bob, you were showing a device similar to this, and you were maybe curious if it was make or break. But really, the reason they put it 180 degrees out of phase like that, so the counterweight itself, and to provide double the thrust, so it's pushing this way towards a small lead,
Yeah, you
unless
should
it's
look at
reversed.
Stoyan-Sargachev's one because in Stoyan-Sargachev's reactionless propulsion device, he had it on a pendulum, but he put it in an enclosed glass tube.
Yeah, we
So
put in a
the
vacuum
question
chamber.
of reactionless propulsion being actually an ionic wind went out of the window.
Yeah, exactly.
Yeah, exactly. Yeah.
Yeah, and that's based on Joseph Campbell's thruster from 2001. He's a NASA scientist that made that
Yeah.
design. He found that was kind of optimal for running thrust, and Nam Tran had built that model and shipped it to me. And so we're kind of a global effort already working on for with APEC for alternative propulsion. And I believe a lot is related to EVOs, exotic vacuum objects, and researching, Ken Shoulders, study into it, and then his interest in John Hutchison. And I've been talking with Charles Holmes about that mostly through email. We had one talk before this
Mhm.
where we could maybe discuss how I could best help with projects like that. And I did see on your channel there was someone already doing the Hutchison effect. So I like his ideas with experimenting. Hopefully we could build devices for them to add to that setup and just prove upon it.
Cool. Hank, you've disappeared. Are you still there?
I'm back.
Okay.
The connection was lost and he was reconnecting, so I don't know.
Okay.
That's
Well, awesome, Charlie. I know you're quite into what you're doing there. So, and I was actually on one of the recent Apex when it was. Uh, I, I think I need to mute your mic, Hank, because there's a fold back. Okay. I'll if you need to speak, just I'll unmute it. Yes. Um, yeah. So, and I saw you going around your. In fact, I think it was on one of the Evo Labs calls. You walked us around your. I think it was your
Yes.
bedroom actually.
Yeah, it's my own office here at my house. Yeah.
Oh, right. Okay. Okay. So you got some quite interesting kit there. Well, I don't know if you saw that I was working with Paul Harris on a first attempt at an independent Hutchison replication there up in Western Canada just a few days ago. I'm about to release a small video in the next couple of days. I just haven't had time, and I'm in about 10 hours I'll be on a flight to Asia. So I'm a little bit exhausted and I don't know which part of the planet my head's at, but I know I'm exhausted. Um, so it's not getting any better. But anyway, we will be looking to do another run of that in the sometime in after May, probably in the summer. And there will be a conference it's planned in Canada, and I'd be happy for you to come, and Henk also. It would be absolutely great. There's some things that we were missing from that, in my view. We were missing some traveling wave tubes, which was a big thing of John's work. Also, his disruptive discharge generator, ours was a little bit meager compared to his, which typically were these Navy Xenon searchlights. We just had a Xenon high intensity discharge car light, which whilst it was ridiculously noisy because the Cockcroft Walton had a spark gap in the air, it wasn't really the one that John used in 2007. It's in the German lab, and it was physically that kind of big in your hand.
Yeah.
This is for illuminating clouds and airplanes. So, but of course, it's not on a permanent arc. He used it in a spark domain, but given the fact that the spark is then enclosed in its shell, it makes less of a really. You have no idea how annoying that was. For the best part of a day, listening to that.
Yeah.
And what you also miss because of the noise cancellation on the microphones is we use Joe Parr's 51.54 frequency that he found, which is the angle, 51.5 degrees angle of the pyramid that he used in his experiments, where he had things doing very weird stuff. That you can't hear because of the noise cancellation. But oh my God, it was so pleasant when it finally went off, because he's got these wall of speakers there, and they were just constantly putting out that hum. But it was good fun, and it's only a few days old, and it's received more views than almost any video. It's the 10th most highest viewed video in 12 years.
Good.
So it's got good engagement. Now, after the test, almost immediately after, I had a jacket. It's kind of like an indigenous kind of like jacket with a zip, and the zip had broken. And I asked Paul if he had a pair of needle nose pliers that I could just crimp the head of the zip to put the little tag back in place. And he went and got a pair of pliers. He handed it to me, and I went like that, and it just broke in my hand.
Wow. Yeah, that sounds like a Hutchison effect. Yeah.
Yeah. So I have this picture of these broken pliers, and it spent most of its time out of what I would have said is the non-radiating boundary. And when I say that, I'm electrosensitive, and where the second laptop was, which is the one I'm speaking to you on now, which, by the way, it and a second laptop that was within that non-radiating boundary both lost the ability to charge. In fact, they had zero charge on the battery, but after about 4 or 5 hours, they got back the ability to charge. So the two laptops did this, and my head in that area was like, it was really unpleasant to be in that zone, like deeply unpleasant. So I imagine that John would want it to have. He always seemed to be away from the target area with a lot of metal in between him and the target area. Oh my God, it was. I don't know whether it's because we had those two, microwave horns doing phase interference with 180 degrees out of phase and the phase conjugation going on. I don't know, or whether it was the sound. I don't know. But for me, it felt like the problems I've had sometimes when I've been very close to a LENR reactor, or in the presence of an operating ultra experiment, or before lightning storms. But it was actually worse than the feeling that I got before 2 lightning storms. So whatever was going on in that zone affected me physically, mentally. And 2 laptops in that zone, and just outside that zone was this pair of pliers, and the pliers, like I said, snapped, and it was a bit of a surprise that the guy that works there, he says, I use those pliers every day, and I did not give it a lot of force, but they were brought to me. I literally we turned it down. I said, "Oh, can you find me a pair of needle nose pliers so I can just fix this zip?" He went and got it, brought it to me, and I was sitting by my laptop inside the non-radiating boundary, and I just went like that a couple of times, and it just broke in my hand. So we didn't get any lift, at least I didn't see any. But is that disruption? I don't know. But certainly there was a disruption to the ability of computers to work. Oh, and the other thing, and this is less significant, of course, you would expect it. When we discharged the large Tesla coil the first time, it broke the second stream, which again was inside the field. Inside the non-radiating boundary. But there's a gantry there and it looks down. So what I'd like to ask you to do, therefore, is to maybe touch base and keep up. And there were several things when that stream went out that John discussed as being important, and those things might be useful to capture. And we know that we were missing the one megahertz RF that he said was critical. He told me that years ago. I've got it on a recording. And so we need to have that. Now, Paul did find out that he had that available, but it would need several days to get, or a day to get operational. So he's thinking, and I said I ideally wanted just 6 of the Therafies. I didn't want 8, but the way he had the standard units configured, they can drive 4 units each. And afterwards, he did say probably he should have configured it with just 2 on one of the drivers, but he wanted to have match load. So he's thinking of making a custom 2 and a 3-phase Therafide driver that just drives 6 units, so that we can arrange them and get a tighter tour on those aspects of it. Well, obviously, John didn't have those things, but since this overall process seems to work in many different ways, it's we're going with what we got and making sure everyone knows exactly what it is. Whereas in John's case, it's kind of like he said he's not a scientist. He freely admits he's not a scientist, and I've seen several versions of the system in George Hathaway's archives, and they were all supposed to work or did work, and so, like, given the fact that they're fairly varied, then I think there is some flexibility. So it's about the actual thing that causes the process rather than the specifics. Of course, we were sitting on a metal frame gantry up there, 3 or 4 of us watching at one point, with a lot of other stuff up there. And given the fact that the pliers had potentially been embrittled, it's a bit of a worry. So I'd kind of want to move the experiment a little bit further away, which means big reorganization of the lab. And I want to discuss that with Paul before the next test. I'd prefer it was in a completely empty warehouse, but John obviously had so much metal around, and I've postulated personally that the metal might have been a source of chi. It's just accumulated it over time, and it is able to be sucked out of it by the vortex that's produced by the overall system. So I don't know, but I do know that in cavitation systems, they stop producing the monopoles if you just leave them in one place after a short period of time. So you have 2 choices. You have a large reservoir of them that you could draw from, or you generate them, because there is insufficient in a normal volume of space to, I think, create the effects. You need to either have it outside with a very high polarizing field, like a thunderstorm, a very active hurricane parked off the coast to provide a decent flux of these things, or you need a generator like the disruptive generator, which is known to produce it. And then you guide them with traveling waves. As far as I understand it, they sit on the nodes and they can travel with light. So I don't know if you caught it, but I analyzed some experiments that were done by Zatelepin and Baranov in Russia. It was in the Russian conference. You can go and see it. I analyzed the materials. They used a spark discharge or exploding foil inside a glass tube around which they wound glass, not plastic, fiber optic, glass fiber. And they then wait till Hank comes back. Are you there? Okay. All right. I can't hear you, but I can see you, so that's good. Okay. Um, they fired not a very powerful laser into one end, and then they passed the output of the laser into a chamber filled with CO2. And in the kind of, you can imagine water spraying out of a pipe, underneath where the laser went, there was a trail of white deposits, and this formed over time. And they sent me this, and I analyzed it, and it was high in aluminium and oxygen. So it synthesized, it would appear from CO2, aluminium, and oxygen, and it seemed to be like a aluminium hydroxide to a degree, because it kind of moved when you put the electron beam laser on there. You can't see hydrogen in a in an SEM. However, when you produce aluminium from fusion of carbon and oxygen, it's actually an exchange reaction. You get carbon, oxygen fuses to aluminium and hydrogen. And so therefore you have a balance in there of some oxygen, and because it's CO2 in there, you have oxygen and hydrogen. And so you should get some water forming. And so that would explain the observables. But of course, this is direct sequestration of these monopoles and using those to cause the fusion of CO and CO2. The issue with that is it really aluminium, or is it some kind of magnecule, as someone has said in the past, our Italian friend? He suggests that these things are bound together so strongly that they even analyze as new elements, but they're not actually those elements. But whatever, it's sequestering them and it's producing a more denser form than the gas, and it's a solid material rather than a gas. And so, given that light can transport these things through glass, that both shows that they are neutral and that they can be transported by coherent traveling waves. And so if you have a traveling wave tube and you've got some phase conjugation going on in there, and you are producing these things, you can target them, and they basically are moved by the light through whatever medium, and then you're targeting those produced ones onto the sample. And so I believe this is a good proportion of what John was doing. So in addition to the spark gap producing the monopoles, it was also being shown by Dubner from 2009 onwards that they are produced by gamma sources. And of course, you're getting gamma sources from the uranium ore and the uranite. And John Hutchison, in many experiments, had uranite in his experiments. It was pretty high activity, the sample we have. And in fact, there's a lot more of it outside in a very large bucket. So next experiment, we might make it a lethal one to stand around. No, the uranium ore is not that like dangerous because most of it's alpha particles. But certainly the alpha particles even are coming out with sufficient energy to punch the water in the air and ionize it and end up producing charge clusters, which are these overall things or can feed to them. And so I think we had the right components. We're missing the correct frequency. We were missing the intensity of production of charge clusters and the absence of a store, because they bind to magnetic materials. So ideally, what we want is very, very large lumps of iron all around it as a feedstock. And the iron probably needs to be just left outside for a long time, just to accumulate them from the environment. And the experiment wants to be ideally run within 2 days of them being brought into situ. So these are kind of some of the concepts that I want to explore, and any other understanding that can come from interactions with George Hathaway and with John in the interim time. The great news is this is inspiring John to bring forward his much procrastinated, let's say, or it's difficult because he wants it to work, and he wants it to work so badly, I think, that he's wants to get everything in place that he thinks would be necessary. Meanwhile, I think that we can keep doing a regular attempt at it, and hopefully the gantry framework doesn't collapse in the meantime. keep the action in the target zone is ideally what I want. So it was quite flexible because the microwave horns we could move from around about 1 to, I don't know, you can see on the video, gigahertz. And you can switch them in and out of phase. You could get them to do phase locked sweeping and traveling. So they were quite nice. They're stupid expensive, actually, for what looks like little things. But they were a flexible thing. But I don't know whether John had that kind of control. John, also, something we didn't do is we didn't have someone sitting there on an AM radio monitoring whether the clicks and pops were getting bad. But I don't know what it would have been like given the fact that we had a big sparker in the environment. I think every single pop would have been on the radio anyway. So that's it. So yeah, in summary, and I'll do a short summary video. In fact, this video here could well be a summary of the observations, and I'll just do a blog with the link on there. With the laptops charge being unable to charge. I mean, it was quite scary. I just bought this new laptop, and and it was like I pulled out the power, and it was like the battery's not working, and pulled it, not charging. So yeah, it was a bit scary. Fortunately, I bought 3 years Apple Care before it arrived. Of course, Apple's not going to be watching this, so I don't have to worry about that. Yeah, so and the other laptop and the general feeling of psychological issues and overall malaise inside the non-radiating boundary. I certainly wouldn't want to spend much time doing those experiments within that zone. And you could feel that it was basically like we had some field meters, and there was high field, and then we went up in the gantry, and it was basically very low. So whatever was going on, it appears to be, fairly tightly confined with everything. So that's the summary of that. Do you have any thoughts on that?
Yeah, could you find this non-radiating boundary? How clear is it? How can you indeed feel or measure it? I mean, when you go out and in the zone, there must be a place where.
I mean, the zone happened to be, if you look at the flyover with the drone we did, where the laptops are is almost where the boundary is. So it's almost like there I felt really bad, but all I had to do was to move about 1 meter away from that, and I felt fine. And the boundary, if you did a hemispherical or even a almost spherical radius around the sample table, you could imagine that if you drew that to the desk with the laptop, then and brought it up, the area that we were filming from with the camera was outside of that zone, and there was didn't feel at all a problem there. It was a real pleasure to be sitting up there and running the experiment.
Could you because the dimension of the experiment and the non-radiating boundary is something that should comply to the sacred geometry. So you could have...
that was the aim of the experiment. That was the aim of the experiment. In fact, there was a small experiment we did with just 2 tubes, as close as we could get them without them arcing between their single point electrodes. that drive the therifiers, and you see, I think I've shared this. He puts an iodine tube in between them, and it actually works out that the non-radiating boundary in that configuration, when you had the vortex and the anti-vortex, and I guess they were about that far apart. It was the non-radiating boundary. I did a 3D model. I calculated it's actually almost it's inside the ends of the tubes, so you could comfortably sit around that. And I felt no effects from that at all when we're running it. Actually, I didn't put my head inside the volume, but then I'm getting very close to those high voltage electrodes on the back of those tubes. So it wasn't something I wanted to do. But when you start putting 8, this is why I wanted 6, because I wanted it to be much tighter so that we could work outside of the calculated non-radiating boundary. But his configuration that he felt he could do at the time, and he since revised that, was with 8. And inside there's if you look at the second stream under the table, it's a double-ended Tesla coil. Okay. And so it's in the black box, and that's what drove one side drove 2 of the tubes, the other side drove another 2 of the tubes. And then on the gantry, if you look at both of the streams, we're looking down on another box, but it's rotated 90 degrees. So they're orthogonal on their overall field structure. And again, it's a double-ended Tesla tube in that box, and each end feeds respectively 2 tubes. So, but because of the size of it, when I was because I've almost got to feel it intuitive. Firstly, it's not optimal because it's not nowhere near tight enough. It needs to be much tighter. So if you look at that first video where that's almost correct. It's not perfect, but it's almost correct. And so it is a very tight sphere. The other experiment, you're actually making a absolutely not optimal ring. It's not optimal. So I almost didn't expect it to do anything, and I was surprised when it was such a strong feeling in the overall environment. And you can make tours that are inefficient and they're big. But like as you pull them in, the gravitational vector, everything else goes up and up and up and up. It's I don't think it's linear either. So this is the thinking. It comports with what was said by John Archibald Wheeler. When you get these things producing gravitational waves, then as they pull in, the energy in the core center goes up and up and up. And it produces its own next order gravitational effects. So with 6, you can with 6 it massively reduces the size of the inner tor. So that would be the target for that part of it to be improved for the next experiment. I'll wait until Henk comes back. Okay. All right. Do you have any questions, Charles?
Yeah, I was thinking we can have George Hathaway, fill in more because he knows the Hutchison setup better than anyone, probably, even Hutchison himself. And I think maybe next call we could invite him to talk more about it. But I think he's tried several times, and with his book Mind Bending, he might still have the theory. I mentioned that during his APEC talk. I had a question if he still thought it might be a plausible theory that it might be a PK, like a psychokinetic effect from John Hutchison. So that's
he definitely believes it. But so there's 2 aspects to that. We know people can manipulate metal using PK. So, and it's not a unique thing to John Hutchison. We've got Ninel Kaligina, we've got Uri Geller, but we also have Dr. George Eagley told me that in 1983 he was filming young boys in Israel doing this on the street. Well, he was trying to film them. Basically, he said none of the equipment worked nearby them.
he built the Eagley wheel too.
Well, yes, that's what he markets. Yes, that's the guy, and he's an expert in ball lightning. And he was the first Soviet-era scientist in the 1980s during the Soviet period to be brought to a US nuclear facility, Brookhaven National Laboratories. And he actually met Uri Geller, and he saw him bend a fork, and he nicked it and put it in his pocket, and he realized it was continuing to bend in his pocket after he put it in his pocket. So, you know, Yin Gazda attended the Jack Houck 1980s spoon bending parties, and you know, so these things are possible, and it's not a unique thing to John. John, I believe that the intention is manifested through charge clusters, but partially you can guide them by the ones that come out of your own fingers. So um, I have remote viewed. I do think I'm cheating in a lot of my research. I don't think I'm doing all of the work. I think I'm remote viewing it. I certainly get downloads, and the downloads turn out to be right in the fullness of time. So regardless, I might be very lucky. So I feel I might be in a position with my electrosensitive nature, which is something that many people have that are able to do these things. I have a good chance, and so I actually the previous day I made a point of, and I'll share this video of taking each of the sample types and holding them in my hand whilst putting my other hand on the high tension Van de Graaff generator for some minutes. And so that the charge clusters had to pass through me and into the samples. But I was very conscious of just enjoying the experiment and the theater all, that I wasn't creating any intention to see them bend. So you're like, I was just so enjoying that, because I've been waiting to do one of these experiments ever since. You know, I was interested in John long before I had an opportunity to meet and engage with him. But like, it was kind of like, we're giving it a go. And yeah, so like next time I shall try and be more focused. But I think it is a technological process, and I think by introducing fixed magnetic fields in there, you might be able to manipulate the charge clusters that are built up. I don't think we had enough time to build up the charge clusters, even if we had enough source of the charge clusters. John's experiments were typically much longer, and we just didn't have um, uh, sufficient time. But in the round, given the observations, both the psychological, the physical, the equipment failure, and the physical failure of um, well, maybe I can show you it, and then I don't have to put it in a thumbnail, and
Sure.
hopefully Hank will come back in the meantime. Let me see if I can find it.
Yeah, it reminds me of John's neighbors in his apartment. You know, they would say they would see furniture move around or ornaments, turn to powder. So the effect was pretty big, and it could even affect maybe the clouds or telephone poles outside with some
I would
sort of
definitely
weather.
imagine it would affect clouds and any kind of resonant structures and material that's able to absorb these things. Yeah, definitely all possible. Henk, are you there?
Video froze.
Give me a second to see if I can get this image for you, and hopefully he comes back. Can you message him and see if he's actually there? Da, 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 da. Uh,
I don't think so.
okay, yes.
No, one difference though was maybe pulsing the spark gap, because in Hutchison's effect, you would turn it on for a time, then turn it off, and then sometimes you would see things move even when it's off, and then
Well,
pulse it
yes,
back
and
on.
that's something we didn't do enough of, because here's the thing, and this is what I found interesting with the pliers, because it was just after we had shut the experiment down. I mean, literally within minutes. And uh, when you are building a charge cluster, if it doesn't get to the point of turning something to jelly, this is my hypothesis. If it doesn't get to the strength of turning paramagnetic materials like aluminium to jelly, uh, or get to the strength where two monopoles can get so strong they cause the fracture in something like a piece of iron, they might be working to weaken at crystal grain boundaries, like is what's the case with when you've got metal bending. Hank's joining us again. Hi, Henk. Yeah. So I'm just about to
Yeah,
share the we've got two of you in the room right now. I can remove one. Let me remove that.
that's great.
Okay, good.
Okay, great. I don't know what is happening.
Yeah, it's okay. Um, okay, so let me see if I can share this image of this pair of pliers here. Can you see that?
And how does it look under the microscope?
Yes. Yep, I see it.
So it just
Yeah.
fractured here. Now, granted, it is where the spring is. It is the weak point in this pair of pliers. But I didn't provide a lot of force. And it was just weird. When it broke in my hand, I go, what? Now,
Yeah.
could it have been because I had too much on my hand? Well, I don't think so. I think Paul handed it to me by touching the end, but I think when I was holding it by the insulating section. So
Problem
from
is
my point of
pliers.
view, I don't think it was anything
The,
I put into it.
the problem is not the pliers. It was you. You were getting Superman, becoming Superman.
Well, I did think that maybe I was applying a lot of force, but I just, it was not a very thick piece of metal that I had to crimp. Um, and so there was no real reason why this should fail. I mean, some things just fail because they fail and that's their time to go. But it was a little
Yeah.
bit suspect that it was in literally within a few minutes of shutting down the experiment. And as Charles has just said, I'm going to stop sharing that now. Charles has just said, and this is, I've noted it by looking at John Hutchison's thing. The very famous one is where he turns off the power when the boat is floating in the water, and immediately you get the charge clusters eating up and traveling around on the surface of um, uh, the aluminium boat. And in the case of Matsumoto's work, some of the videos, you can see the ball lightning is moving around and doing a similar kind of thing that you see on John Hutchison's work. However, he's pulsing it. So he's turning it on and then turning it off. So like they're kind of like switching on and switching off, switching on and switching off, and they're moving around and doing their business in the meantime when there's a downtime. So I think what can happen is that you build and build and build these things, but they are literally electromagnetically confined by the standing waves. And when you turn off the standing waves, which is feeding them more monopoles, they go, we're free to go and eat shit. And that's kind of what's going on. So like that is another aspect so really kind of what we want to do is go through these kind of learning parts from the first attempted test and then try and employ these in a more thorough test next year. And so it would be great to have both of you there. I think maybe it would be good, Charles, for you to coordinate and um, be able to maybe provide another Tesla coil or a Van de Graaff generator. The thing was is the Tesla coils that Paul had there, he'd built himself, but they were so big you could only run them outside. He says they throw 1 foot or whatever art, so they're doing 1,000,000 volts, but they're just scary to have around any other equipment. And John really settled on using Van de Graaff generators and keeping a really good top load. And he talked about that post the experiment and asked Paul where he sourced his top load because it's kind of the size that he wants. And so I think we've got that bit right. But the other Van de Graaff generator failed. I don't know if you saw it on the video, but the base of the device, you could see it on the second stream. It lit up, and I think it was about to catch on fire. So yeah, the belt or motor, the motor had worn out. I don't know what happened, but it was glowing like a ball lightning, and we weren't prepared to keep it running. So we lost that, and maybe that's part of the overall system because I was very keen to tell Paul, we need fairly large space because John Hutchison had the Van de Graaff generators, the vacuum polarizers, at 15 feet away. And the reality was we were only about 6 or 7 feet away with one from the apparatus, and the other one was even closer. And that was very close to what would be the main toroidal structure if it's made in the ether. So that might have been part of why it failed. And so I think really we need to do what John did, which is have the polarizers quite some distance away. And again, that involves a bigger working area to be made. So, but yeah, these things are all possible, and you know, we learn and we move forward, right? So,
Yeah, I'd
and
love to
I
join you.
hope that within the window between now and the next test, John delivers.
Yeah, keep
It would be
trying.
awesome.
It seems like it sounds like you're getting something already. I'm working on a spherical Tesla coil design. This was a design from Sean Calderon. He has increased the inductance by having multiple layers in here, and it produces an effect where it won't light a neon bulb, so it won't interfere with the electronics, but it will produce like a foot of sparks.
Wonderful,
It's an
wonderful.
interesting
Good job.
design. Yeah,
Yeah.
love to finish this and bring it with me
Yeah,
next
yeah,
year.
yeah, yeah. I mean, if we can get a good few days and we can do a bunch of tests and basically monitor them around the clock, we can like this is what we're going to do here, this is what we're going to do here, this is what we're going to do here, because we don't want to change too many parameters. Because then it starts to become, well, you don't know what did it. So yeah, we can move forward with come up with a selection of hypotheses. I presented partial parts of my thinking, which were unable to be achieved with that first test. It's encouraging what happened, you know. When Paul was setting everything up, we were like, are we going to have big holes in the ceiling, or is the cannabis plant next door going to disappear and we've got something to answer for?
Yeah, never know.
You know, be like, oh dear, I don't know what happened to your building.
Yeah.
Wasn't
Building lift off.
you what? What do you say?
Building lift off.
Well, yeah. So there is that. Now, Charles, you're probably in a position, I don't know whether this is true, to do an independent replication of the Vega Valley. And Henk is really the person to walk you through that. But as far as I'm aware, it's a DC biased, a couple of 100 volt DC bias with a AC component on top with up to 700 and something volts discharge, and it's a normal propane tank with some judicious holes cut into it with some quartz windows and some ingenuity put in there, some electrode pass through and a quartz or so sheath around that to protect that from spurious discharges, but also to provide a witness material. And then the anode goes on the end, and essentially the whole thing is it a floating ground, Henk?
No,
The
well,
cathode is put at ground, is it?
yeah, exactly.
Okay.
Yeah, I
Yeah,
can
that makes it a little bit safer.
I can touch the reactor. I regularly touch the reactor so I can
Yes.
feel where the heat is.
Right. So it's best to keep the ground as the cathode, and then
Yeah.
the anode is the the material on the probe that goes through the top. And
But it's also connected to the transformers, so that it's a disconnect from the
yeah, so
mains.
it's isolated.
Yes, exactly.
Okay. And then the how's it? The gas manifold system is fairly simple. Henk uses
Yeah.
a bicycle in a tube for capturing small amounts of gas to be
Yeah,
put in there.
that's the point. Yeah, and just needle valves, small ones, and the 12 millimeter or 10 millimeter tubing, and that's it. And then four entry points, so I can mix some gases. That's it. And I put a vacuum pump on it as well.
Yeah, I mean,
So
the
the
original
vacuum pump.
experiment of the Vega Valley was done without a very fancy pump or a very fancy
No,
pressure valve.
no, nothing is fancy in my whole experiment. Everything is second-hand, cheap stuff from the internet. I
I
have
mean,
no
the,
money
the,
to.
the, the good things to get are the capacitors, getting the good type of capacitors. And
10 microfarad. I got an old capacitor from a friend, and it was 6 kilovolts, 6,000 volts, and 10 microfarads or something like that, and one is 40, but that's not really important.
Like
No,
these,
no.
No, they're big fat
they're
ones.
bigger. Okay.
These are
The big
let's
ones.
see. This Heidi can't see it on the screen.
Yeah.
About that big. Okay.
Yeah.
I've seen some like from Information Unlimited. Yeah. That size.
So these are huge ones. So don't touch it because it probably kills you, and it really gives a nice bang when you shortcut it.
Yeah.
It's
There's
fun
a
to
lot of
play
punch
with.
it can deliver, and I
It's
think
very-
that is the key to the process. That
Sorry?
alongside, you need it that big to give it the punch.
Yeah, but still, the plasma is very, very, very strange stuff. Of course, it's you need a current source because this capacitor, this size, that when you charge it to maybe I did probably 3,000 volts sometimes to start the process. Well, it really gives a true bang in the whole system because it discharges really fast, and this plasma in this discharging mode is like a shortcut. So this is a really strong pulse of current, and then the voltage drops very quickly to maybe 400 volts to stop the whole process again, and then it starts again. So I have this pulsing system sometimes, and then I have to go to a lower vacuum to get it into the glowing plasma, the regime, and then suddenly it's totally different. It's always amazing how this transition goes on. This is like magic. There is some arcing, nothing, and then you pump a little further, and then suddenly the whole thing changes, and boom!
I'm sure it's something to do with the overall build-up of charge clusters, the passion curve, the optimum level of
passion curve is
ionization.
absolutely, yes. No, well, it must be very complex. Very likely people have found out. Many people have been.
Well, this is the point about doing replications and methodical testing is to find out, which parameters are driving what.
And probably the Sapphire team found out again. They have tons of experimental information, of course, stored in the computers, but they don't share anything about it. So,
well, like I say, we shouldn't, as an open organization, ever rely on a third party to show us how to do it. We've got to show them how we did it, and they can either agree or not. It doesn't really matter because once it's done, it's done.
Doesn't matter. No, it's true. But
yeah, so
to measure the vacuum gauge is okay now, but the pump probably has to be the scroll pump. I don't know. It has to be faster, and so you can start and put on a computer system so you can start, let's say, sweeping through or pressure or gases or voltage or current and sweep through whole areas so that you can find sweet spots, because I know they are there, but they are short-lived. And then it's gone and you can't replicate it because you don't have the parameters. And then
I mean, the thing is, if you're aggregating gas and fusing gas, you actually change the pressure.
Yeah, I know.
If you're synthesizing gas, you're changing the pressure. You're changing the gases.
Exactly, and that's why I had these gas samples, because when I was producing the gas, I was very puzzled. I mean, I could keep on pumping and pumping and pumping, and when I shut the whole process, the pressure didn't really change. Put on the process, and I was producing gas. I stopped the plasma, and it stopped producing gas. Or maybe there was a little leak in there, but it took hours to.
Well, I mean, with Irving Langmuir, he found that even with a small tungsten filament light bulb, he was getting 7,000 times the volume of the mass of the filament. So, what chance have you got with a massive drum, like with a huge tungsten electrode or something?
I don't know, but it was this big brass anode, I think.
Right.
And there was a time that you were around, and that was, I was explaining it, and I was trying to capture this gas. It is not easy process. and it's not a slow process. It took a few days to assemble this gas, but and it's still not analyzed. Tone has no time to analyze it. He's
Oh,
got this
that's a
one.
shame because
It's a very shame.
I'm going to
It's
Taiwan. I might have been able to take some. It's just a shame.
it's a shame.
Yeah, okay.
But okay, he is busy and we are all busy, blah blah blah. And so sometimes things don't happen, or maybe it's again some low-hanging fruit kind of stuff. But
I
maybe
think
it's
it
not.
probably is low-hanging fruit. So we should probably focus on getting that tested. You know, it'd be great if we saw helium in there. There shouldn't be that much helium in there, but also
Exactly.
since
Something like
oxygen is the most abundant element in the Earth's crust, and if we're saying that the Earth's crust has been synthesized by this process over time, it could be the case that a lot of oxygen is being produced. Certainly, carbon seems to be produced, and it's the next alpha particle conjugate nuclei on from that. So it could be that a load of oxygen is being produced, and of course that would change the dynamics.
the point is, where does it come from? Because I didn't put anything in there. It was not. It's more like it's coming out of nowhere. That's
It's not.
more
It's coming
my.
out of. It's coming out of the materials, possibly physically coming out, but also transmutation. So
Yeah, it could be. It's just a guess for me because where there's only iron and dirt, of course.
damn it.
Lost.
Yeah.
But it sounds like low energy nuclear reaction, like
Yeah,
a,
yeah, yeah. It's quite likely.
Mhm.
Hank? Okay. So yeah, it's a relatively easy experiment to do, but it's physically quite large and it's quite dangerous. But then you're probably okay working and boxing things and making things safe in a way that Henk probably doesn't feel the need to do because he knows what's the nasty bit and stays away from it. Uh,
Yeah.
So, but it would be great, and essentially, Hank would be able to tell you this himself. But underneath, you have a sheet of brass, and then on top, you have cut sheets that are have a variable gap. And when you have a non-perfect edge, you're going to have all kinds of different micrometer gaps between the two plates on the top. And so this allows for various resonances to occur, and this appears to be where the fluidized electrons are produced, and then they bleed out between the two brass sheets and do their magic. And so it's a very good experiment, and it would be great to see a third party outside of Henk replicating it because it's a unique experiment which we learned so much from about how this process works. So there's that. And then I've said this to Griffin Brock, although he was meant to we were meant to have a call at his request on the 16th or 17th of December. And he wrote to me yesterday, having missed my message on the 16th, because he's got so many orders for his
Yeah.
tube.
That's my fault. Yeah, I bought two.
You bought two, and I don't think you're the only person. He said,
No, that was like
he says,
1,400
maybe next
easily.
week I might be able to take a call. So
Yeah.
absolutely snowed under with production,
It
which
takes
is
them four hours to make each one.
yeah,
I've seen 'em.
but I'm very happy for him. I'm really
Mhm.
happy. It's just great, and he deserves that.
Yeah.
And to have actually attempted and improved upon the designs and actually
Mhm.
taken it to live. And of course, when David Butler, my colleague, found that he was producing these things and got one and spoke to me about it, I said, I'll have to have the electrode. And oh my God, did the electrode deliver? It went way beyond what I could have dreamed I would find on there and became very precise. So what I want to discuss with Griffin is that, for instance, in the work of Vysotsky in cavitation from a water cutting tool, that is a device that uses high pressure water to cut through even quite thick metal. It produces cavitation induced radiation that by taking metal plates with holes in it, they could show the light, the whatever it was coming off would expose X-rays, and it would be co-limited, or some might say collimated. And this is to say that the light rays are parallel. And when I was looking at Griffin Brock's things, I don't know whether he discusses it in his videos, but certainly it was obvious to me that they were clearer, and they're clearer because they work differently. They are co-limited. And what I'm saying there is, when you have a normal X-ray, you have the electron beam going to a target, and the target, it's hitting there, and it's going all through the metal, and it's producing all kinds of Bremsstrahlung radiation to produce the X-rays, and then it comes off, but it's a diffuse beam, right? And so you have to have the source quite close. So, for instance, if you've gone to the dentist, you'll have the source right here, and you'll put the X-ray right behind. And there's practically millimeters, or certainly no more than centimeters, between the source and the device. Again, if you go and have a chest X-ray, they'll put the plate behind you, and they'll put the X-ray source just in front. So there's not even a foot there. He's getting clear images at 15, 20 feet of complex structures. And the images of his face, his foot, and bone are far superior. And that actually is similar to what if you look at that comparison he shows, where you've got Röntgen's Röntgen ray and the radiant energy shadowgraph of Nikola Tesla. The Nikola Tesla one looks clearer. And I believe that this is because they're collimated, that they are, and I think that it's because, and he says that it becomes a tighter and tighter beam as it warms up, and I think it's because the subtorque clustering is ending up by taking the spread beam, which we know it will do it. In fact, it will produce a vortex. And it's pulling it into a tight beam, and the tight beam are essentially parallel rays, and or very much more parallel than come out of an X-ray. So it is a far superior technology. The question is the health risks from it less or more than X-ray? And I suspect they're going to be less if you're using aluminium. And I wouldn't want to use the aluminium source for a long time, because it starts synthesizing other elements. And so there's a question there as to how good it will be for producing the same kind of low damaging radiation over time. But I certainly think initially it would be better, and I think actually the X-rays should be replaced with this technology, in my personal view. It's better imaging technology. It works. The only thing is, you probably have to always fire it up into the sky, because it's going to be X-raying everyone else in the rest of the building as they're walking by. Normal X-rays get stopped by not a lot of material, but this doesn't. So. And I don't know whether we're going to get Henk back. Do you have any questions on that aspect? And you're going to be looking at too, and I look forward to seeing what you come up with them.
Yeah, I've been emailing back and forth. He's not yet selling the power source, which is a high frequency, high voltage Tesla coil spark gap.
Well, there's an opportunity there for you, isn't there?
Mm-hmm.
So, like, maybe you could co-brand something. That's straight up. So if you can produce a suitable device, David said his voltage on his device was only 1/3 of Griffin's, and that's maybe why he couldn't get the real-time shadowgraphs. And I don't know what imaging sensor he was using, but you would almost certainly want an old style. I would say a TIV 900 or something similar, which allows for full capture of the frame rather than a rolling shutter. So you buy one of these old, beautiful 3CCD devices, and they produce spectacular quality for a CRT, and you can record it on video or whatever. Not a more modern video device. It is true, I think, that you can get, how should we put it, really sensitive industrial and scientific global shutter CCDs. So I would recommend one of those. And given the fact you're not going to see color anyway, you might as well use a black and white sensor of that type. And they're readily available. Global shutter, high frame rate, or high pixel density uh, scientific cameras, and I would use that. Looking for the sensitivity would be advisable, because it might be that whatever David used is not just the low voltage on his driver coils. It might be that the imaging is actually subtler than you think. Whereas the X-ray is very sensitive at 400 ASA, the multiplier screen that he's using, that type of multiplier screen, might actually produce, whilst it's high fidelity, a low difference in the level of luminosity between the luminous parts and the non-luminous parts, in which case you need to have the ability to see low levels of illumination and stretch the contrast out to define the image. So I can help you at that point, because I've been doing this kind of stuff a good proportion of my life. But if you can make the drive coils and maybe co-brand, something with him where he can sell your stuff and you can sell his, and it's a big virtuous cycle. So.
Yeah, I've been emailing him about a different topic though, for using them for propulsion, because they radiate an energy like the asymmetrical capacitors. So I think using that strange radiation, that shadow graph like projection of energy, it could be used in propulsion. It's already in a vacuum tube too, but I like to put it in a vacuum chamber. I could share a screen to show you.
It would be great just to do the experiment. Yeah, I saw this in the APEC meeting.
Yeah. So I helped with that setup.
Yeah.
Diagram and Navtran to help with that. And we got it going, but we want to do some other experimental changes to it. And the plasma toroid and his high voltage DC circuits, just spark gap experiments. So I wanted to share with Hank here, and just high voltage DC. And here's one with the test the coil using the spark gap of water and a magnetic field. Experiment. And then finally, I wanted to mention, the Campbell thruster, but experimenting with Tesla coils and high voltage DC. The Tesla coils didn't affect it as much as I thought it would. But hopefully, if I get the one wire capacitors, then going with, I could use it with AC to produce the thrust. In this case, it caught on fire, but you get the idea. They'll spin around like a carousel when it's working. And again, with Boyd Bushman, I put together this playlist. I don't know if you have time to watch the
send it to me. But like, I'm meant to be packing for my flight in 6 hours, 7 hours.
Yeah, maybe you could download it. And this one he talks about his magnetic beam pattern.
David I talked about that on my hacking the neutrino verse video. So you might like to go look at that.
Yeah, I talked with David Soretta, and he sent me this. He hasn't yet uploaded it publicly, but I uploaded it, and he'll eventually put it into a movie or documentary.
Cool.
In the near future. And I've got someone else.
So I think that's a good idea on using it, looking at it from a propulsion perspective. Just put one on a pendulum and do what what's his name did, Steinsarg. Just hang it and just give it some impulses, or vary the voltage or other parameter space. Keep it operational. You don't want that structure to die and have to rebuild itself. So keep it operational, but vary the intensity and try and you might be able to have something look at the position of the pendulum and trigger the pulse every time it crosses. So you just have some sort of a tag on there with an octo whatever, and just pulse it every time, so that you're actually working with the oscillation frequency when you're adding the impulse. You're providing the impulse at the correct time. So, something along those lines, and that will show that whether or not it's producing a net force fairly trivially.
Okay. And Griffith Brock did experiments with electroculture to see if there's any effects to biological things, and they seem to grow fine. And under microscope, the cells were very similar. Under X-rays, those do produce ionizing radiation with the DC cathode rays that are used in that circuit. So because he's using AC, it's like radio antennas and Wi-Fi. It's not as damaging to people who be near. So I think that's why it's safer.
Yeah, I think where he has it, the structure that's built on there, it's definitely throwing the beam out one side. it would seem. And technically, it should throw a beam out the other side, but it doesn't. I did see a cheap Chinese-made Crookes tube. I've got pictures of it for Griffin, which had a much simpler construction for the attachment of the nickel electrode. So he spot welded his on the back, which provided some consternation and pause for thought with what was potentially going on the electrode, which I'd like to be resolved. But regardless, they actually had lathed a disc, and then on the back of the disc there was part of the same consistent aluminium billet. There was a pillar, and the pillar was drilled. And then all they did is they put the nickel in the back, and they just crimped it. So there's no spot welding in that apparatus. Now, the block of aluminium on the back, will that change the electrodynamics in that? I don't think so. So it would be interesting to see if that much simpler, because you can CNC the aluminium bit fairly readily, easily, from a straight. I mean, you lose a lot of the material when you're lathing it. You go like that for each of the sections, and then you cut it, and then you drill the back end. But there's no need for a spot welder and all of that potential contamination that introduced, because there's copper on there, but the copper's likely come from the copper electrode on the spot welder. And it would be nice to kind of like remove these variables from the analysis so that we can be sure of what's going on. Do you have anything else to add on that?
Well, thank you for your time. And yeah, I agree. We could do an experiment in, in Canada when you do the next testing with that maybe next year, and work with Hank here. And sounds like a good idea. Either I could replicate his setup or send him circuits to help improve his design.
Fantastic. And the last point I suggested to Griffin, I was going to flesh out what I actually was going to ask from him. I've asked Paul the same, and I've even asked Grok, because I might build it myself, and I'd like to get a bit of a competition. I'd like a circuit that can drive 2 or 3 phases up to 6,000 volts. I've said 6,000 volts because you can work with semiconductors. You don't have to go into the realms of funky stuff. 6,000 volts, as high DIDT as possible, and be able to change the pulse width and phasing on the phases.
Okay. Yeah, sounds like a good project. I gotta play up with that too.
So I have a special use case for that, and my target is to start testing with these various. Whether I make it, this third party I'm going to be working with, this Paul, yourself, or Griffin can come up with whatever, whatever it is that'll be done. It's going to be shared, but I think you'll like it.
Yeah, sounds like a good project. I'm excited to see what it's used for, but it'd be a secret for now.
Yeah, it'll never be secret, but yeah, it'd be interesting to see what people think I want it for.
Yeah.
So if you're okay, I'm going to publish this video probably in the next 2 days and see people to comment. Thank you very much for taking the time to speak with Henk and I, and for considering working with the project. And well done on your demonstration of the propulsion there. And I think what you're seeing is something that you're going to see, something that's a little bit more amazing in the coming year. Let me put it like that.
Yeah.
At the moment, I just want them to just say this is how it's done, and here the anti-gravity craft, because it's just going to be embarrassing. It's just going to be embarrassing. So if you're listening, US Navy, just come out with it. Just show everyone. Just, I don't know, do it on Trump's inauguration, do the flyover and save us all the hassle.
Yeah, that'd be good. Yeah.
Just save us all our hassle. All right. Cheers, mate. I've got to get ready to go. So
okay. Yeah.
thank you.
Safe flight. Thank you. You're welcome.
Cheers, Charles. All right. Bye.
Bye. Bye.